So yesterday we talked about sequences. Today we're going to talk about series. And so the difference is that in order to come up with the series, we need the sequence. So we rely on the sequence first to determine the series. Series is just the sum of the numbers in the sequence. So you take that sequence that may already exist or that we may need to find, and then you just add those numbers up. That is the series. There's two different kinds of series that we'll talk about, okay? And so I'm going to give you both of them. We'll start with the first one. The first one is called an infinite sequence, or infinite series, And that's basically when we add up all the terms of an infinite sequence. So we talked about this yesterday. An infinite sequence had the braces around the a sub n, and then it goes a sub 1, 2, 3, and it keeps going forever. That's why there's no term at the end of these three dots. When we add them up, that's called an infinite series. Now, sometimes we will have an infinite series, and we'll have to see if it has a sum. Because if you think about it, if you add things up forever and ever and ever, it may keep growing, and it just may approach infinity. But there are other circumstances we'll be looking at later where an infinite series can actually equal something specific. Like I said, we'll get into that later. Mostly, and what you're going to be doing today is dealing with a finite series. Okay? And a finite series is what we call it the nth partial sum, because we're finding a sum of the portion of the sequence. So for example, if I wanted the 10th partial sum, I'd be adding up the first 10 elements of that sequence. And most of what you're going to be doing today is that. You're going to be adding up terms of a finite sequence, which gives me the sum, which is the finite series, okay? Or also known as the nth partial sum. That's what we're mostly going to be doing today. We'll get into the infinite series later. But the notation in order to find those sums is really the bulk of what we're going to be focusing on today, just to get us used to that notation. So on the next slide, I'm gonna have you take a picture of the next slide, but don't take it right away, because I'm going to fill it in as we go, and then I'll let you know when you can take that. So the start of the next slide, I know it's really small, the Greek letter sigma, and I'll zoom this. Hopefully. That's a capital sigma. In statistics, we talked about a lowercase sigma when we were looking at standard deviation. This is a capital sigma. Okay, and in a few short months, some of you are going to learn more about Greek letters than you have in a long time, because you're going to be rushing for a fraternity or a sorority. And so maybe now you already have seen some of these Greek letters from a brother or sister or a friend, but sigma comes up all the time because that's prominently used in fraternities and sororities. Today, that's not what it refers to, but you might as well get used to it, okay? It means summation, and it's a concise way of writing out a series so that we don't have to necessarily write it all out at once. But that way you kind of see where we're going to start, where we're going to end, and that's what the rest of this slide is going to have on it. Okay. So don't take a picture yet, because I'm going to still add some more to the bottom. All right. So this means the nth partial sum. Okay, S sub n, sum of the first n terms. Okay, here we have this little letter. I know it's a script I, and it's hard to see, but it does not mean the imaginary number. That is the actual index. That's why they use the letter I. And it starts with the first term, and that's the lower limit. Then the upper limit is n, and so I'm going to take the first term and add all the way up to the nth term. And the way we indicate that is the first term plus the second term plus the third term plus the whatever term all the way up to the nth term. We add that all up, and that's our nth partial sum or our finite series. Okay. We can also have an infinite series. And now you can take a picture. The only difference between what we see up here and down below is notice the upper limit is infinity now, and it doesn't end. There's not an ending term. Okay, so yeah, go ahead and get that into your notes. So what I need to do is show you how this works in practice, so we can get it going, and I can show you how to find those finite series or those nth partial sums. Okay. So on the next page, I'm going to give you a couple examples. We're going to go through 3 examples in total. We'll do the first one and talk through it, and then we should be in good shape after that, okay? So here are my 2 examples for starters. My third one's going to be on a totally separate slide. And then once you get those things written down, I'm going to change the size of the screen again so we can see it a little better. But notice here, on this first example, the lower limit is 1, which means I'm going to start with the first term. The upper limit is 5, and I'm going to end with the 5th term. So I'm going to take the first term, the second term, the third term, the 4th term, and the 5th term and just add those up. And for the second question, now the lower limit is 3. So instead of starting with the first term, we start with the third term. So I go to third term, 4th term, 5th term, 6th term, and then add those up. Okay. Yeah, these do take a little time. Now this second one will be a little trickier because we've got the fractions and the exponents. But this first one won't be bad. One of the things I really encourage you to watch for are patterns, because like you said, it could take a long time to do, but if you recognize the pattern, that cuts your time down, okay? And so one of the things that I'm going to ask that you do in your homework is write all the terms of the sequence out. Don't just type it all in the calculator and give me an answer, even though the directions are going to say find the sum. I want to see the numbers of the sequence that you're actually adding up. So for this first example, I'm going to show you the first few elements of the sequence, and then we're going to hopefully see a pattern, and same with B, okay? So for A, I start with the first term, where the index is 1, okay? So I just plug 1 in for I. And notice here, this all equals, so this is just the first term right here, 2 times 1 plus 3. I just replace I with 1. This gives me the first term. So what is the first term here? 5. 2 times 1 plus 3 is 5. Okay. Now we follow the same process for the second term. So instead of plugging 1 in, I plug 2 in. All right. So what is this? 2 times 2 plus 3? 7. All right. So if we were going to predict what the next term will be, what would you say without doing anything? 9. We think it's going to be 9. 5, 7, 9. Let's test it. And then if it is, we can find the last 2 terms without doing any work. All right. So I plug 3 in. 2 times 3 plus 3. Does this equal 9? It does. That's good. So then I would stop. I'm confident that that's the pattern. I would not show any more work other than write down the next term is going to be 11, and then what's the last term going to be? 13. Okay? So most of you probably reach for a calculator, but you could also add that up in your head. What does that all equal? 45. Right? Because here's 20, here's 12. 12 and 13 is 25, and 20, 45. Okay, so this one equals 45. That is the 5th partial sum, or the finite series. All right. Now, are there any questions on that? Again, look for those patterns. If you can find those patterns, that'll make your life a little easier. All right, let's look at question B. Question B. Now I went ahead and I have all the rest of the work, but we didn't need to do that once we found the pattern. All right. Now here you got to be careful because we start with the lower limit of 3. So we're finding the third term first. And so I've got to replace all the k's. And we did a problem like this just a little while ago. So I plug 3 in. Negative 1 to the third. We talked about this when we went through example 41. Is this 1 or negative 1? Negative 1. And then this is 1/3. So the first term is just negative 1/3. What's going to happen to the next term? Negative 1 to the fourth. What's that going to be? In terms of sign, positive or negative? Positive. So the next one, okay, this is where we get that alternating thing going on. Negative 1 to the fourth is positive. So I get positive and then 1/4. All right, so without doing any work, I should be able to come up with the fifth and sixth term. What's the next one going to be? Negative what? 1/5 and then 1/6. Okay, so then I just follow that pattern. Now you can get a common denominator and add them up, or reach for your calculator and do it that way. I don't care. Okay, but at that point you have to find that sum. Okay, so why don't you go ahead and do that, and then we'll look at the very last problem. What'd you get? Just say it. Negative 7/60. That is correct. Okay. Negative 17. Again, I put all the work up here, but once you find the pattern, go with that. Save yourself a little bit of time. Negative 7/60. Obviously, this problem has fractions in it. Your answer should have fractions in it. One more example I want you to be aware of, because this one's kind of weird. All right. We're going from 1 to 6, and it's of 3. What's the problem here? What's the issue here? There's no n. Okay, there's no place to plug the index into. So there's no n. So each term, regardless, is going to equal what? 3. It's always going to be 3. It can't change because there's no n that I can plug a value into that will change the value from 3. This is what's called a constant. Okay, so I still have 6 terms: the first term, second term, third term, fourth term, fifth term, sixth term. So what ends up happening in a situation like this, I actually add 3 together 6 times. First term, second term, third term, fourth term, fifth term, sixth term. What does this equal? 18. Okay. So when you are in a situation like that, if you ever see a problem like that, just know you're just adding that value to itself, however many terms there are supposed to be. Okay? Questions on any of that series stuff?